Alright guys, in this section we're going to be looking at solving quadratics, and the method we're using here is the graphing method. Now before we start getting into examples of solving quadratics using the graphing method, a couple of things that we're going to need to know. Because we are going to be graphing these quadratics, the thing that we're going to be looking for are the x-intercepts. And because we're looking for the x-intercepts, we're going to come across three different possibilities. As you can see on my first graph over here, one possibility is that we have two x-intercepts, one here and another here, which means we would end up with two real solutions. Another possibility would be a quadratic or a U-shaped parabola that only has one x-intercept, like this one here. And if that's the case, we're only going to have one real solution. Now a third possibility is that we could have no x-intercepts, as we do over here. Notice that this U-shape does not have any x-intercepts. Therefore, we have no real solutions. Now, we do have solutions that we'll talk about later on, but at this point, there's no real solutions. Now, some terms that we're going to need to keep in mind are down here at the bottom. We could be referring to the solutions to the quadratic, but some other terms you may come across are finding the zeros of the quadratic. You may also be asked to find the roots of the quadratic, or you may be asked to find the x-intercepts of the quadratics. And all of these terms mean basically the same thing. We're looking for the x-intercepts on the quadratic. Alright, so let's make sure we keep those terms in mind. Now let's go ahead and take a look at some examples here. Alright, first example we have is x squared minus 11x plus 28 equals 0. So since we're solving these quadratics using the graphing method, the first thing we're going to want to do is graph it. But keep in mind, before we can graph this, we do have to make sure that the equation is equal to 0, which in this case we do have it equal to 0. So now that I have my graph, what we're going to be looking for are the x-intercepts. And you'll notice that this particular graph has two x-intercepts, which means we should end up with two solutions here. So those are the solutions we're going to be looking for. So one of those solutions would be this x-intercept right here, and that x-intercept is 4. So one of my solutions is 4. We have another x-intercept, which means we have another solution, and that x-intercept is right here, and that x-intercept is 7. Therefore, our two solutions to this quadratic are 4 and 7. Again, we do have two solutions because we have two x-intercepts. Now all this means is when I plug in 4 for x, and I'm plugging in 4 for both of those x's, what I should end up with is a 0. So if I put this in my calculator, I should end up with a 0. Same thing is true with 7. If I replace x with a 7, and I enter this into my calculator, once again I should get an answer of 0. So again, the two solutions to this quadratic are 4 and 7. These are the only two values that make this statement true. Okay, example number 2, we have x squared minus 3x plus 2 equals 0. Again, before we can graph this, we do want to make sure that the equation is equal to 0. Once I have it equal to 0, then it's just a matter of me graphing this on my graphing calculator, which in this case, this is the graph that I end up with. And because I'm looking for the solutions to this quadratic, I'm looking for the x-intercepts on my graph here. As you can see, we do have two x-intercepts, which means we have two solutions. One of those x-intercepts or solutions would be a positive 1, and the other x-intercept would be at positive 2. Therefore, my two solutions to this quadratic are 1 and 2. Once again, all this means is if I replace x with a 1, it's got to be in for both x's, that I should end up with the value of 0. If I do the same thing with 2, replace x with a 2, this will also give me an answer of 0. So the only two values that make this equation equal to 0 are 1 and 2. Okay, example number 3, we have x squared plus 12x is equal to a negative 36. As you can see, this equation is not equal to 0, so the first thing I'm going to do is make this equation equal to 0. And I can do that simply by moving my 36 to the other side, and we can move that 36 to the other side by adding it. So now what we have is the equation x squared plus 12x plus 36 equals 0. So I do want to make sure I get this equation equal to 0 first before I graph. So at this point, I've plugged it into my calculator, and this is the graph that I end up with. Now you'll notice that this particular parabola, or U-shape, only has one x-intercept, which means we're only going to have one solution to this quadratic. And that solution, or x-intercept, is right here at -6. Therefore, the only solution we have is -6. Once again, all that means is if I replace all of the x's with a -6, again, it's got to be for both x's, the value I end up with is a 0. So if I put all of this in my calculator, I should end up with a 0. Okay, example number 4, we have x squared is equal to a -7x. Just as in the previous example, we want to make sure that the equation is equal to 0 first. So I'm going to do that by moving my 7x to the other side, and we're going to do that by adding. So at this point, I now have the new equation, x squared plus 7x is equal to 0. Now I'm ready to graph this. So again, if I enter this into my calculator, this is the graph that I end up with. Notice how this parabola, or U-shape, has two x-intercepts, which means I'm going to have two solutions here. One of those solutions is right here at 0, so that's one of my solutions. I also have another x-intercept over here, and that x-intercept is -7. Therefore, my two solutions to this quadratic are 0 and -7. Once again, all this means is if I replace each of the x's with a 0, I should end up with an answer of 0. Same thing is true with -7. If I replace each of the x's with a -7, I should end up with an answer of 0. So again, the two solutions to this quadratic are 0 and Alright, example number 5, x squared plus 3 equals 0. Since this equation is equal to 0, I can enter this into my calculator. And if I enter this into my calculator, this is the graph I end up with. Now, you'll notice that this particular graph has no x-intercepts. It does not touch the x-axis. This is the x-axis here. And because there are no x-intercepts, we have no real solutions. Okay? No real solutions. Now, we'll talk later in a previous, or in another video about how to find those imaginary solutions. But at this point, there are no real solutions.